Hello everyone, learn chemistry with Bukem. Today's topic is oxidation and reduction reaction, and this class is applicable for 10 to 12th grade. So learning objective. At the end of this class, you should be able to define oxidation and reduction in terms of oxygen transfer and electron loss or gain. And you should be able to identify oxidizing and reducing agents in a chemical equation. Understand the concept of redox reaction, and you should be able to apply this concept to real world examples like corrosion and combustion. The key vocabulary, that is subtopic under oxidation and reduction. So we'll be discussing oxidation, reduction, redox, and oxidizing agents, and also reducing agents. Oxidation, and what is oxidation? Is gain of oxygen or the loss of electron during a reaction. Reduction is the loss of oxygen or the gain of electron during a reaction. Redox reaction is the reaction between oxidation and reduction that occurs simultaneously. That is, if oxidation and reduction reaction occurs simultaneously, we have a redox reaction. Oxidizing agent is a substance that brings about oxidation by being reduced. Starts with oxidation now. The classical and modern view of oxidation. So firstly, let's look at this little diagram before even going to the theory aspect. Let's look at this diagram. So you can notice from this diagram an electron is being an electron is going out. Can we say this electron is going out? So this signifies that this is a metal, so it is losing an electron to become a positively charged. Explain oxidation in terms of oxygen. So now, in terms of oxygen, oxidation is the addition of oxygen to a substance. So whenever oxygen is added to a substance, we say oxidation has taken place. An example is magnesium bonds in air. So when magnesium bonds in air, plus we have magnesium plus oxygen to give us magnesium oxide, this equation here. So that is an example of oxidation. So oxygen has been added to magnesium to give us magnesium oxide. That is oxidation reaction in terms of oxygen. We can also explain oxidation in terms of electron transfer. So in terms of electron transfer, there's an acronym used, which is OIL. Oxidation is the loss of electron. Oxidation is defined by the loss of electron. Remember the acronyms OIL. OIL simply means oxidation is loss of electron. So an electron is being lost. So mostly metals lose electron to become positively charged. Example is zinc. Zinc lose 2 electron. Zinc plus 2 electron minus to give us zinc 2 plus. Using 2 plus. So in this equation, oxidation has taken place because zinc has lost electrons to become positively charged. Initially, when zinc is uncombined, we can see this zinc is uncombined. It's not combined with any other element. So zinc here is 0. The oxidation number of zinc here is 0. But now in this situation whereby zinc is now having an ion, now we can see zinc is now zinc 2 plus, so the oxidation number here is plus 2. From 0 to plus 2, that means oxidation has taken place. It is increasing towards the positive side. Initially zinc was 0, lose electron to become positively charged, to become plus 2. So that is an example of oxidation. So now let's test our knowledge. Test your knowledge now. Oxidation can only happen if oxygen is present in a reaction. Is it true or false? It's time to explain. Oxidation can only happen if oxygen is present in a substance. No. Since oxidation is defined more broadly as loss of electron, which can happen without oxygen. So the equation I gave on the zinc, you can see that when I gave zinc plus 2 electron minus to give us zinc 2 plus, I did not add oxygen to that equation, and I also said oxidation has taken place. So oxidation can take place even without the presence of oxygen. So you can see the answer is, the first one is the answer. Oxidation is defined more broadly as the loss of electron, which can happen even without oxygen. Now, reduction and the partner process. We just talked about oxidation. So oxidation and reduction are partner process. Oxidation cannot take place without reduction. So if oxidation is taking place, then reduction must also be taking place. So now, reduction is the removal of oxygen. So can we say reduction occur when a substance loses oxygen? So when oxygen is removed from a substance, we say reduction has taking place. For example, heating copper 2 oxide with hydrogen. Heating copper 2 oxide with hydrogen will give us copper plus water. So from this equation we can see that oxygen has been removed from copper to give us H2O. So in this reaction, it has lose oxygen. Oxygen has been removed from the equation, from the chemical equation. So we can say reduction has taken place. We can say reduction is the addition of hydrogen. Hydrogen has been added to this equation, and we are having copper plus H2O. So this as reduction can also be explained as addition of hydrogen. Now, in terms of electron gain now, we have an acronym for oxidation as oil. So in this situation, acronym for reduction is RIG. Reduction is gain of electron. So let's look at this diagram too. Let's look at the diagram of this neutral atom. You can see an electron, this orbital has gained an electron to become negatively charged. An example is chlorine. This is the example, Cl plus electron minus to give us Cl minus. So in this situation, chlorine has gained electron to become negatively charged. So this is an example of oxidation in terms of electron gain. So on the next slide, I have a redox equation. I explained earlier that a redox equation is an equation in which oxidation and reduction occurs simultaneously. We cannot have oxidation without reduction, and we cannot have reduction without oxidation. So now let's look at this equation now. How will you be able to recognize oxidation and reduction reaction? So let's look at it now in terms of electron loss now, because there's no oxygen or hydrogen attached to this. So let's explain this in terms of electron loss or electron gain. We can see, and zinc is here. Zinc here is uncombined, so this zinc has oxidation number of 0 because it is not combined with another element. It has the oxidation of 0, and our zinc here has the oxidation number of +2. Zinc here is +2. So now this is from 0 to +2. It is increasing towards the positive direction. So this is oxidation. It is increasing. Oxidation is it's loss of electron. That means it lose electron to become positively charged. So that is oxidation, moving towards positive direction, increasing from 0, 1 to 2. Now reduction now. The copper here, let's see copper here. The reduction is the reduction gain electron to become negatively charged. That means to be reduced towards the negative direction. So this copper here now, the oxidation number of copper here is +2. We have +2. This is +2. Cu2 plus 2. And going to the product side, the oxidation number of copper is 0 because it is uncombined. It is not combined with any other element. So when an element is uncombined with any other element in a reaction, the oxidation number is 0. So now we are moving from +2. Copper here moving from +2 to 0. It is moving towards the negative direction. That means it is decreasing. So that means reduction has taken place between this copper here and the other copper here. So this explains redox reaction. So in this reaction, a redox reaction has taken place. That means because we have oxidation and we also have reduction reaction that has taken place in this equation. Let's continue. How can you identify an oxidizing and reducing agent? We'll just explain an oxidizing agent. This is the electron thief. It takes electron from another substance. So an oxidizing agent takes electron from another substance. Oxidizing agent is the site where the reduction is being made. Example now. So in this equation now, to be able to identify the oxidizing agent here, we can see this is oxidation takes place here. So this site where oxidation takes place is called a reducing agent. This one is a reducing agent. Is reducing agent because where oxidation takes place, where the particular element that lose electron to become positively charged, that is the reducing agent. So our zinc here is a reducing agent. So our copper is an oxidizing agent. And why is copper an oxidizing agent? Copper is an oxidizing agent because this is the site where reduction is being made. So the site where reduction is being made is called a oxidizing agent. So copper is an oxidizing agent. Why is zinc is a reducing agent in equation. Zinc is a reducing agent. Now let's continue. Now I said the reducing agent, this is the electron donor. It gives away electron. Zinc is the reducing agent because it loses electron to the copper ion. So I've explained this earlier. I've explained this. So let's go to the next slide. Now let's match the terms now. So this is just like an evaluation that we should answer. Match this term. Let me explain this evaluation. Now rig is reduction is gain of electron. So we can match this with this. Reduction is the gain of electron. Rig reduction, that is the gain of electron. Now oil is loss of electron. Can we see? Oil is loss of electron. Redox reaction is a simultaneous reaction between oxidation and reduction. While reducing agents is a substance that lost electron. This reduction. Summary now, putting everything together, this is the final takeaway. Oxidation and reduction always occur together. They are two sides of the same coin. So one does not occur without the other. You can't have oxidation without having a reduction reaction. You use oil and ring to remember electron movement. So oxidation and reduction in terms of electron transfer, you can use oil and ring. Oil simply means oil is oxidation is loss of electron, while ring is reduction is gain of electron. In Nigeria, we see redox action every day through the rusting of iron. So when an iron rust, oxidation and reduction reaction has taken place. The combustion of fuel in a car in a car engine also requires oxidation and reduction reaction to occur. So that is an example of oxidation and reduction reaction in the world generally. That's an example of oxidation and reduction reaction. So this brings us to the end of today's class. Thank you for listening.